Alright, we're into a new chapter, technically chapter 4, but we're going to get into electrons and their levels. All chemical reactions are based upon the interaction of electrons of one atom with another atom. When a collision occurs between atoms, which is what starts a reaction, it forces electrons the option to go to another atom or back and forth between atoms or whatever is created, which is something we're definitely going to delve into later on. There was a guy by the name of Niels Bohr. Niels Bohr was a Danish scientist who had issues. Now, hopefully you have seen Mr. Anderson's video. If not, you need to shut it down right now and watch that before you go any farther. But what he basically said was that electrons have to be traveling around in some kind of fashion around the nucleus. Now remember, electrons are negative, protons are positive, protons are in the nucleus, so it's positively charged, and there's going to be a certain amount of attraction to it. And as Mr. Anderson alluded to, there's going to be an attraction to bring them in, but to keep it out is going to create energy changes that are reflected in the way that he described. Now, most people, when they're taught about the electrons in an atom, usually do this kind of thing. You've got this circle. Oh, that's horrible. And let's say that we have the nucleus right smack in the middle of all this. Put that right there. Now remember, the nucleus is minuscule compared to the size of the atom. But all the mass is concentrated right there. Now, Bohr stated, and had experimental proof for this, that every level existed in its own entity. In other words, electrons can be found here. We call this level 1. We use the symbol N for that, which is part of the quantum theory that we're going to get into for this later on. And the electron is buzzing around in whatever fashion. It doesn't necessarily have to be a circle or a sphere, although on the first level that's exactly what it is. The farther out you get, the more likely it's going to take other path forms, which is what we're going to talk about next. But this is called the ground state. N1 is the ground state. This is where it's normally found. Now, when you get bigger atoms, the ground state is going to be farther away. But we're just looking at hydrogen, because that is what Bohr based his ideas on, was the simplest of all the atoms, which is the hydrogen. Now, in order for the electron to move out of there and go to another level, it has to absorb energy. So like photons, which are packets of energy given off by electromagnetic radiation, particularly the sun and its light. These little packets of energy hit this and the electron absorbs it, and it absorbs enough protons to be able to jump to another level, which we call N equals 2. This is called an excited state, where it's normally not found. So we'll say anything past 1 is considered to be an excited state. This jump from one level to another, this jump is called a quantum leap. And there was a famous show on ABC about this, but they didn't really take this seriously. It was all about time travel. It was actually a pretty good show, but it had nothing to do with the theory we're talking about. They just liked the name of it and made a show out of it. Anyway, so, excuse me, his basic idea was that there's all kinds of energy involved here. You have to have X amount of energy to exist in this form, X amount of energy to get it to move away. Remember, this is positive right here, so to move away, it requires energy to be absorbed to get it yanked over there. It's just like magnets. We have a positive, negative magnet stuck together. You can feel the energy to pull that apart. And it takes, and the farther away you go from the nucleus, the less pull the nucleus has on the electron, so it takes less and less energy until you get all the way to infinity level, which means that the electron is out. It's gone to either another atom or it's come off as some other particle by itself, which will immediately, when it bumps into something, become absorbed by that. Okay? Now, you're going to need your periodic table for this. I have the one that I gave you way back when, chapter 1 or chapter 2. And if you pull out yours to follow along with this, I've supplied a version of this on the assignment for this. Now, there's a reason why this chart is laid out this way. And it's a very odd shape, but man, the meaning behind this is pretty dynamic. Electron levels. Every level that you go farther and farther, remember the levels are going to get bigger and bigger and bigger as you go out. So you can see, like if you think of this three-dimensionally, and the sphere that is created is the limit that it can go, but at the same time, because of all this dynamic volume, shall we say, you can have electrons, fit more and more electrons in the bigger areas or volumes than the smaller volumes. And so the farther out you go, the more electrons that you can hold. And that's what we're going to be looking at today, is how we can predict how many electrons can hold. Now, in middle school, if they taught you this, from what I understand, and for good reason, they said, well, they all travel in these little spheres, these little circles here, so just put all the electrons on there. So like, we know that the second level holds 8 electrons, they put 8 E's on there, and oh, that's all pretty and everything. And it served its purpose because it told you how to predict the number of electrons you can for each level. What we're going to do now is we're going to take a much more in-depth look to where they actually go. Okay? So it turns out that the first level is exactly as was probably taught to you. And that is, this first row right here represents hydrogen and helium, as you can see, but those hydrogen and heliums represent the 2 electrons found in the first level. So that first level right here, you're going to have 2 electrons bebopping around there, close to the speed of light. And they're going to be opposite each other, one spinning one direction, the other spinning the other direction. There is a spin number, what we call an S number, involved in that, and they're going to pair up. Okay? Now, so we know there are 2 electrons in that first level, and it turns out the amount of energy it takes to put a helium, the second electron in helium, in after the first electron, which would be the same amount of energy that the first hydrogen, the only hydrogen electron has, to get it in there. But when you put a second one in there, it doesn't like it as much because you already have a negative particle traveling in there. You put one more electron in there, it's got to be exactly opposite because they repel as far apart as you can. And remember, they're moving at the speed of light, so there's all kind of energy fluctuations going on here. It's crazy. Speed of light. Can you imagine going almost the speed of light? Now, it's just short of it. But we could not survive traveling close to the speed of light. Yet these little particles, these electrons, which have virtually no mass and an extremely small amount of volume involved in it. In fact, some people argue maybe no volume, but we're not going to get into that. But those 2 are found in that first level. The second row, you count the number of atoms we have in the second row. 1, 2, 3, 4, 5, 6, 7, 8. You got 2 over here and 6 over here. That gives you 8. So let's take a look at that. So level 1, we have 2 electrons represented by the hydrogen and helium. Level 1. Level 2, we have those 2 electrons. We have these 2 electrons right here, and these 6 electrons over here. So it's divided into 2 parts here. There's a reason for that as well. But we're not going to get into that as well. Okay, so level 2's got 2 electrons on the left-hand side, plus 6 electrons on the right-hand side, for a total of 8 electrons. Okay? Now that's pretty predictable. You look at the charts, okay, that makes sense. We're in good shape. You'll notice though, and as I just described, every level you go past the first level, you can have more and more and more electrons depending on how far away you are. So level 3. Now so far, level 1 is found in row 1. Level 2 is found in row 2. Now why am I putting up the obvious? Because it's not so obvious for level 3. Here's what happens here. Now, here's row 3. Row 3's got 2 electrons over here and 6 electrons over here. Well, that's the same number as level 2. And that's the issue. There are more electrons that can be held in the third level than is indicated by the periodic table. But if you take a look at the gap between the 2 on the left and the 6 on the right, you count these columns right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons. Those 10 actually belong in the third energy level. Okay, and I'll explain why or what happened there, but let me put this number up here because this becomes really important. So level 3 has 2 electrons plus 6 electrons plus 10 electrons, which is a total of 18 electrons. Now, if you remember your days from middle school, they taught you to put all those little E's or X's or whatever it is they told you to put on the circles. The third level they said was 18 electrons. Why? Well, this is why. Why is because this is supposed to have been over here. But it turns out the amount of energy it takes to put it into the third level here is more than these 2 right here. These 2 right here are actually 4th level electrons. And they fill in first. And then you get all 10 of these to go into the third level. And then these over here go back to the 4th level. There's 6 more over there because it takes more energy for these 6 to be filled than these 10 to be filled. And these 10 take more energy to be filled than these 2 over here. So it's all about the ability, the amount of energy you take to put it into the atom. Okay? Now, let's take a look at some really interesting mathematical properties here. You'll notice level 1, 2 electrons. That's it. Level 2, 2 electrons and 6 electrons. That gives you a total of 8 electrons. Level 3, 2 electrons plus 6 electrons plus 10 electrons gives you 18 electrons. Look how much we increased as we went by level. What happened numerically? Do you see a pattern in the numbers 2, 6, and 10? Yeah, they go up by 4. So the next level, level 4, we should expect to see 14 additional electrons to the 18.